Hello children, hope all of you gone through the last class that was the continuous charge distribution. And now if we take a surface enclosing the charge plus q, then the electric field will be radially outward. If we take a small area ds whose area vector is not along the direction of electric field, that is making some angle theta with the E, then what is the flux? That is flux equal to E dot ds, and here electric flux is equal to 1 by 4 pi epsilon naught q by r square r cap dot ds vector. If we resolve it, we will get E ds cos theta. Now electric flux is a scalar quantity, so its notion is simple. How we can find electric field by using electric flux? For this purpose, we have to know the Gauss law of electrostatic. Today, in this we will get the statement of Gauss law, significance and Coulombs law from Gauss. First of all, the statement of Gauss law, which goes on, the electric flux through a closed surface is 1 by epsilon naught times of the total charge enclosed by the surface, that is phi E equal to q by epsilon naught. Now how we can prove this one? So let us a spherical surface enclosing the charge plus q, element area is ds, and here the area vector and electric field both are in the same direction. So the electric flux through a surface element ds, it will be E dot ds, and that is 1 by 4 pi epsilon naught q by r square r cap dot ds n cap. Here the r cap and n cap are in the same direction, so its dot product will be 1. So the value of d phi e is equal to 1 by 4 pi epsilon naught q by r square into ds. But our motto is to find the total flux through the spherical surface. So we have to add all the flux coming out from such a small area element, and that will be surface integral E dot ds, and that is 1 by 4 pi epsilon naught q by r square. It is the value of electric field, and the summation of all element area will be 4 pi r square. If we see here 4 pi r square and this 4 pi r square cancel each other, so leftover term is q by epsilon naught, and it is the Gauss law. Advantage of using Gauss law: there are certain features. The Gauss law is true for any closed surface, no matter what is its shape or size. Second is, it is useful when the system has some symmetry. And the third, the Q on the right side of the equation, that is phi E equal to Q by epsilon naught, is the sum of all charges enclosed by that surface, and that surface is the Gaussian surface, and it is based on the inverse square dependence on distance, as in the Coulombs law. So we can say any violation of Gauss law will indicate departure from the inverse square law. Now the Coulombs law from the Gauss law. Once again, we are taking the same diagram. Now, here the electric field at this point we can say it is Q by R square, this distance, into 1 by 4 pi epsilon naught. But from the Gauss law, flux, electric flux equal to surface integral E dot ds, that is Q by epsilon naught. Or we can say vector E dot surface integral ds is equal to Q by epsilon naught. And here the sum of all the element area constituting this sphere will be 4 pi r square. So this term will be vector E dot 4 pi r square Q by epsilon naught. So E equal to Q by 4 pi r square epsilon naught. And now we want to, what is the force if a charge Q naught is brought at E, then what is the force? And we know if a charge is brought in electric field, that will experience a force given by equation force equal to charge times of the electric field present at that point. So here it will be Q naught Q by 4 pi r square epsilon naught. And if we recap, it is the Coulombs law between the two charges Q naught and Q. Now, how we can use to solve the problems, especially the application of Gauss law. Here, see the situation we are taking. Plus 2q and minus 2q are within a surface, and plus 2q outside the surface S. What is the flux through the surface? And second, try to find out the flux of uniform electric field through the surface of a cylinder. Next, we will learn the application of Gauss law, 3 application in our syllabus, that is electric field due to a uniformly charged infinitely long wire, second charged plane sheet, and electric field due to uniformly charged thin spherical cell in next classes. Thank you.